Going to discuss debugging. Many times a program is written, it looks correct, but when it's run, something isn't working quite right. We often need to think hard, and if that doesn't provide the answer, pull out a debugger and run the program through that. I will show you how to run and terminate a program, set breakpoints, single step, skip over or step into a method, view variable values, and finally, to inspect an expression. Debuggers provide more options than this, but these six tend to provide all the function needed for most problems. This program will demonstrate the conversion of hexadecimal numbers to decimal numbers. This code is more complicated than what we've studied to this point. If I kept the code overly simple, it would not provide a good environment for debugging. I looked ahead a chapter to section 4.5 and used the code from the hex digit to decimal program. We find that code in the method defined starting in line 2 and ending in line 10. What we do is take a single character, compare it to the letter A through F, read line 4 as is character between A and F inclusive. If so, we take the character, we subtract its Unicode value for the letter A and add 10 to it. The math here may not be familiar. Don't worry about it. We're talking about debugging. We're not talking about number systems. If the digit is not in the range A to F, perhaps it is a normal digit. We would know them as 0 to 9. The test on line 6 tests that, and if true, returns the digit. Now, the digit, being a character, will have a Unicode value that's very different than the number that we're passing in. Remember, characters are encoded integers. What we have to do is subtract out the smallest digit, which is 0, so that we're left with an integer in the range of 0 to 9. If the character does not match a valid hexadecimal digit, that is 0 through 9 and A through F, line 9 will throw an illegal argument exception saying that character is not valid. To split the hexadecimal string up, which I've defined in line 13, I have a loop in lines 17 through 21. Line 14, we determine the length of that string. In this case, there's 3 characters, so the length would be 3. We subtract 1, and we assign that to a variable called exponent. I'll explain why in a minute. And our starting value is assigned 0. As we do the conversion, we're going to add to it and arrive at the decimal value. Our loop in line 17 starts with a new variable called I. It's assigned 0, and the loop continues as long as I is less than the length of the string. The loop will repeat the code in the body, which is lines 18 through 20, as long as that middle section of line 17 is true, this portion that I'm highlighting. I gets incremented each time through, so eventually I will be equal to 3, and the loop will not continue any further. Line 18 takes as the digit the character which is in the hex string at the index represented by the variable I, starting with 0. This seems a little odd at first, but the first digit is at index 0. So 1 is at index 0, 2 is at index 1, and 3 is at index 2. Line 19 is the heavy math. We convert the hexadecimal digit to a decimal representation by calling the hexadecimal method defined in line 2. We see it highlighted here. That is an entire sub-expression that gets resolved to a type and a value. The type is int, according to line 2, and the value is the conversion of the character that digit represents to a decimal integer. So as soon as hexadecimal does its job and returns a value, what I've highlighted turns into an integer value in the range 0 to 15 for a valid hexadecimal digit. That number is then multiplied by 16 to the power of whatever exponent is. If you remember your algebra well, a number like what I've defined on line 13, 1, 2, 3, and this is hexadecimal, really means 1 times 16 to the second power plus 2 times 16 to the first power plus 3 times 16 to the 0th power. is always 1. So we get 1 times 256, which is 16 squared, plus 2 times 16, or 32, plus 3 times 1. The answer is 291. We loop through the hexadecimal string 1 digit at a time, do the conversion, do the multiplication, and add it to value. In line 20, we subtract 1 from the exponent so that we're always decreasing. The first exponent will be 2, then 1, then 0. I will run it by clicking this green circle with the white triangle in it, and I'm hovering over it, and it says run. Let's clear the bottom so there's no display. Let's click that button again, and you'll see there's the display. 123 hexadecimal converted to decimal is 291. Let's introduce a few new concepts here, such as a breakpoint. Assuming this program isn't working correctly, I need to try to debug it to figure out what's going wrong. To do that, I need to stop the execution of the program at a point where it's helpful to me to look at more carefully the operation of the program. If I just run it like I've done, it completes. And if there's a bug, I don't really know where to go with it. So let's introduce a bug, then try to debug it. What I will do in line 7, comment out the subtraction of the character value for the digit 0. So now we're going to return not a number in the range 0 to 9. Character is going to be in the range of 48 to 57. Instead of 0 to 9, it will be in that range. That's clearly wrong, but let's see what happens. Let's run it first, and I get a really wild number. That doesn't look correct at all. So now I need to look at my program slowly and see what is going wrong. What I want to do is put a breakpoint at a line of code where I want to inspect it more carefully. I'm going to choose line 19. This gray vertical bar to the left of the line numbers, I'm going to double click, and notice there's a little blue dot. That is a breakpoint. The program will run up to line 19 and then stop. If I press the run button, that will not work. What I need to do is press the debug button, which is to the left, and notice it looks like a little green ladybug. My view jumps, and notice the green line is at line 19. That means my program has run starting line 13 all the way up to, but not including, line 19. What digit am I working with? I can hover my mouse pointer over the variable called digit, and up pops this rectangular window that shows me that digit is 1. I'm working with the first digit. Now I know that I'm going to call hex to decimal passing the digit 1. Now this digit is a character, so it has a Unicode value of 49. So I have to convert ultimately that character to an integer. I don't know if that's going to work. What I'm going to do is step it 1 time and see if value makes sense. A single step is this arrow right here. It is a large curved arrow. I click it once and I will step 1 line of code. Click, and notice the line went from 19 to 20. So I have not executed line 20 yet. It's the next one. But line 19 did execute. Now I want to look at value. What should have happened is I should have performed the mathematical computation 1 times 16 squared, or 1 times 256. I can hover over value to determine its number, and we see 12544. Clearly that's wrong. Notice up in the right corner, I have a yellow bar through the variable called value, the number it's storing. Same number as when I hovered over value. So there's a couple different ways of determining what number is stored in a variable. The yellow bar means that that value changed recently. We've determined something is broken here. It's probably in the hexadecimal method. Let's terminate the program, debug it again, and trace the conversion of the character 1 to what should be its integer value. This red box is called terminate. I click it and the execution of this program stops. Let's run it again. I click the debug, and here we go. Because of the breakpoint, line 19, that's where I go. This time I want to go to the code hexadecimal. Previously, I said this single step button will execute one line of code. If I click it, I will execute hexadecimal and the multiplication and move on to line 20. This time I don't want to execute it. I want to go to the method. So I go to the arrow next to it, which is step into. That means step into that method. As an alternative, I could put a breakpoint on line 3 and then run the code. That would also work. I prefer step into. I will click it and you'll see the green bar go to line 3. We are now in the hexadecimal method. Let's see what character N is. I'll hover over it and I see that it's 1. Now remember, this 1 is a character, not an integer. Let's single step and see where we go. We will test to see if the character is between A and F inclusive, and it's not. So we go to line 6. We're on the false path of the first if. Now we have a chained else, so we're going to do another test. And we're going to say if character.isDigit, and we're going to test it by single stepping. There we go. And notice we're now executing line 7. We're on the true path of the chained else test from line 6. Here's where the problem is. We're going to return ch. Now ch, why do I have a variable that's different than the parameter n? To simplify testing, what I did is in line 3, I said character ch is equal to the uppercase of the parameter n. That way I'm always testing uppercase. Otherwise I'd have to test lowercase and uppercase. This just keeps it simple. So now I'm going to return in line 7 the value ch. Now ch is a character. We see in the debugger that ch equals 1. Our minds may be fooled into thinking, great, value 1. So let's step it and we should wind up back at line 19. Everything looks like it's going well. Perhaps we're puzzled because it looks like hexadecimal is going to return a 1. Hexadecimal is defined as returning an integer value, not a character value. So there's been a conversion from character to integer. Notice I've highlighted hexadecimal paren digit paren. I'm going to right click on it, click on this word inspect. That will tell me what is being returned from the method call hexadecimal. And notice the value is 49. That is the integer representation of the character 1. That's clearly not what I want because the math is 49 times 256 rather than 1 times 256. So I realize hexadecimal is returning an incorrect value, even though it looked correct. And after inspecting the code in line 7, I realized I'm returning the character value converted to integer. Now I will uncomment this and say, oh yes, I remember. I need to take the character and subtract from it the Unicode value of the digit 0, which is 48. Character is 49. We subtract from it 48. Answer now is 1. I make the code change. Let's terminate this, clear it, debug it again. I will step 1 time. Now I see value is 256. That makes sense because hexadecimal with the character 1 should have returned an integer with a value of 1. I take 1 and I multiply it by 16 squared to get the value 256. Now it seems like I have my code working correctly. Let's terminate it and let's just run it. And now I see 123 hexadecimal converted to decimal is 291. I believe it is now working correctly. This section discussed techniques that we have not yet discussed. That's okay. The value of this is that early in our course, we're learning how to do some interesting debugging. This should prove to be helpful later in the course. Refer back to this as you need it. Just remember that it's here. To run the program, we can click the Run button, or To debug it, we click the bug to begin execution. We set breakpoints, like in line 19. I will set one in 3 by double clicking in this area to the left of the line numbers. Single stepping is achieved by clicking on the curved arrow button. Skipping over a method can be done by using the single step. If you want to step into a method, use the right angle arrow and then continue using step over. Hover your mouse over a variable name and it will show you the value that it has. Also remember, the upper right corner has a variables window. It has the benefit of showing you that yellow bar for a value that was changed. And finally, highlight an expression, right click, click inspect, and it will tell you what the value is.